A big old ham is launched at a 32.5 meters per second speed at an angle of 80 degrees above horizontal on a level field. What time is the ham in the air? All right. So remember, we got to bust this guy, and it's like it's launched way up like that, right? The hypotenuse is 32.5, right? And let's break this into x and y components, right? So after checking that my calculator is in degrees, I'm going to go 32.5 cos 80, that's my x, 5.6436, so 5.6436 meters per second in the x direction is our initial velocity, right? And then in the y direction, it's 32.5 sine of 80, which is going to be big. 32.006 meters per second in the y direction, because we're nearly launching it straight up, right? Okay, so now we've got these components, and let's see, let's do A and B. Okay, so we're going to do A and B, and we'll do C in a different one, right? Because we can't do it all together. Okay, so what time is it in the air? So it's going to go up. It's going to go. It's going to land, right? So technically, we actually know this. We know this and this. We also know this, this, and this. We can infer this, right? Okay, we can almost get everything except for what we're being asked for, right? So let me explain, right? This we always know, that's 0, negative 9.81, right? Okay. And then the x component becomes this velocity, right? So 5.6436, 6436, right? And then the final will be 5.6436. And the reason is that we're ignoring air friction, and it doesn't have a little jet booster, right? And then this is going to be 32.006. And because it's landing back on the ground, we can use the symmetry rule, right? Neglecting air friction, it hits the ground going the same speed that it was going up, right? Which, by the way, makes this 0 because the average velocity is 0. That's fun, huh? The average is 0, right? It spends as much time going up as down, right? Okay, so how do you find time? My favorite way to find time is to use v equals u plus at. You can use ut plus 1 f at squared, that one, but it's a lot harder. This is much easier. Minus 32.006 is positive 32.006. So this is our initial velocity, right? Final velocity, plus negative 9.81 times t. Now, if you're paying attention, you just take that last component you calculated and go times 2 divided by 9.81. That'll give us our hang time, 6.5252. And then you can fill this guy into 6.5252. Doesn't continue. It's not a repeating decimal, I'm just going to say. All right. And then we can find, on the horizontal side, we can say S is UT. Right, so it's 5.6436 times 6.5252. Okay, so let's see. I'm going to go times. I'm going to find that value I use. I'm using the up arrow on my calculator. 36.8 meters. Now the range equation, by the way, if you give us this velocity, that angle, it'll get at that in one step. That's the beauty of it, right? So we did get the time in the air correct. We got how far it goes, right? So time in the air, it's in the air for 6.52 seconds, right? Okay, 6.53. Oh yeah, because you'd round it up, 6.53. So time in the air is 6.53 seconds, properly rounded with sig figs, right? How far it goes is this guy here, the 36 point S horizontal, right, is going to be 36.8 meters, right? All right. Okay, so in the next video, actually in this video, I'll just do this, right? I'll erase this. So I'm about to erase this. All right, so now let's do C, and we won't be doing this, right? So it's exactly 3.5 seconds after it's launched. Now, by the way, 3.5 seconds after it's launched, is it on its way up? Now I think it's just barely going down. Okay, because it's in the air for 6.53 seconds, right? So at 3.25 seconds, 2515, something like that. Anyway, 2.65. Anyway, whatever half of 6.53 is, whatever that is, it's going to be at the top, right? Okay, so at 3.5 seconds, I believe it's on its way down, but let's just fill it in. I think we know previously this, right, from the components, and this, and this, and this. I think we know this, and then we know this and this. Then we have to figure this out, all the rest of this out. Okay. Since it's asking for just the velocity, really all we have to do is figure out this guy. Okay, so what do we know? Well, the components of this vector, previously we figured out that that is, let's find it, 5.6436. And that's just 32.5 cos 80, right? And then, of course, this is 0, and then it's asking for 3.5 seconds. And then, of course, always know that's negative 9.81. And then our initial velocity here is 32.00. Let's find that. Where is it? 32.006. Right? Now, we could find where it is, but it's only asking us for the velocity. So let's just find that final velocity. V is u plus at. And I'm using the vertical stuff here. So V is 32.006 plus negative 9.81 times 3.5. And this will be a negative number, I'm pretty sure of that. All right, so that guy minus 9.81 times 3.5. Negative 2.32 meters per second. 32, it's negative 2.3287, I'll say. All right, so. All right, so what is its velocity as an angle magnitude vector? Draw a picture of it. Okay, so it's going to be this picture of this guy. So it's this over, this down, right? So let's draw a picture of this. And this down. .3287. All right, I'm going to find the magnitude. My magnitude is the square root of 5.6436 squared plus 2.3287 squared. Notice I'm ignoring the minus sign there, okay? Okay, so square root of the 5 thing. I'm just using the values from my calculator squared. So if you get something slightly different, you're rounding more than I am. All right, plus parentheses. That guy squared 6.105. 10515 or something like that. I'll just say 2. So this would be 6.11 meters per second. That would be the speed, the magnitude of it, right? And then we could find that angle there. This angle here is going to be tan minus 1 of 2.3287 divided by 5.6436. Okay, let's see if I can do that. Tangent of that guy divided by the other guy. Where is it? There it is. All right, are we ready for this? 22.4 degrees. Yay? All right.